End behavior helps us describe how a function behaves at the furthest ends of its graph. So we don't really care what happens in the middle of the graph, really just about what is happening on the furthest left and furthest right of the graph. So when you look at this one, we don't care what's happening in this middle. We just want to focus on these ends. So this arrow means y's keep going up and x's keep going to the left. So as x goes to the left, it's approaching negative infinity. And as x keeps going to negative infinity, y keeps going up to infinity. So we're going to write that as x goes to negative infinity, y goes to infinity. And then over here, as x goes further right, it's approaching infinity. And as x approaches infinity, y also approaches infinity. So again, we're saying this is describing the left part of our graph. As x goes to negative infinity, y is also going to infinity. And then as x goes to infinity, y goes to infinity. For this one, we see that our graph opens down. So our y values are both going to negative infinity. And that happens as x goes all the way to the left and all the way to the right. So our end behavior is as x goes to negative infinity, y is going to keep going down to negative infinity. As x goes to positive infinity, y is going to keep going down to negative infinity. Also note that there's a reason why there's some symmetry here about what y is doing, because we have that symmetry in the parabola. But that may not be the case for all graphs that you'll see. In this example, it's a little different because the right side of your graph keeps going down to negative infinity, but the left side just kind of stops at negative 21. And this happens as x gets closer to negative 2, y is getting closer to negative 21. And then as x keeps getting closer to infinity, y is going down to negative infinity. And so that's your end behavior because we're describing what's happening on the furthest ends of your graph. For this example, as x goes to negative 4, y is going up to 1. As x goes to 0, y goes up to 9. And our last graph, as x goes to 0, your y value is going to 1,500. And this graph is showing the estimated manufacturing costs of manufacturing x number of items. So as we get closer to building no items, we have an estimated cost of $1,500. And as we manufacture more and more items, the cost is going to keep going up. So again, end behavior describes how your function behaves at the furthest ends of its graph. We don't care what's happening in the middle. We just focus on the end.